Okay, so the next thing we want to talk about in terms of statistics is one of the last two things we're going to talk about. It's what's called margin of error. Uh, and that's margin of error in polls. So you probably watch anything on the news at all, you'll hear about this poll or that poll. And right now they're going crazy polling people for president. Um, so assuming the group we've polled is representative of the overall population you want to look at, then it turns out that with what we call in statistics confidence, 95% confidence, meaning that 19 out of 20 times that you conducted this poll, your results would be uh, accurate, then the margin of error, how off you could be, uh, is 1 divided by the square root of the number that you've polled. N is the number surveyed. And that's how much percentage you could be off. So that, of course, will give us a decimal, uh, but then that's the percent we're off, called the margin of error. Margin of error. And so I actually pulled some data here from a recent survey. So went onto the website 538 and found the following information. Take a look at one of these here. So this is a survey from February 20th. The one I'm interested in is the one here at the bottom. In this poll of 1,000 voters in Wisconsin, the poll came out 42% for Biden and 45% for Trump. So we want to compute the margin of error and see, based on that margin of error, can we say who's actually winning? Uh, can we say who's actually winning right now, uh, based on this poll? Okay, so we're going to take a look at that. Again, it's 42 and 43, and let's see where we're at here in this example. So in this example here, again, we surveyed they surveyed 1,000 voters in Wisconsin, and what they found was that Biden had 42% support, and Trump had 45% support. Now, noticeably, that's still only 87%, so there's a whole 13% of people that aren't, coming into this at all, right? Whole 13% of people that aren't being covered by this at all. So we want to compute the margin of error and see what range of values would Trump's actually be. So this is saying 95% of the time, the actual support that Trump has would be within what we compute as our margin of error. So we compute that margin of error, 1 divided by the square root of 1,000. So we just go to a calculator and do that. 1 divided by the square root of 1,000. And that gives me a decimal 0.0316. 0.0316. 0.0316. So we would convert that to a percentage as 3.16%. Okay. So what that means is that Trump's level could be anywhere from 3% above 45 to 3.16% below. So we find that range of values for him. And then Biden's would actually be slightly different. It's not exactly 3% for him because he's the lower one. There's a little technicality in there. But you could basically rough it by saying his could be anywhere from 3% above to 3% below that as well. And this tells us that we're 95% sure that it's somewhere in there. Okay, so what we do is we just take that percentage and add it on. So the high point for Trump could be up to 48.16%, or we can take it off. And of course, that would give me 41.84%. So based on just the Trump range, if we fixed Biden at 42%, we still wouldn't even be sure that Trump is actually leading. So this here is within the margin of error, clearly. So we really can't say for sure on this one who's leading, who would be leading here, because it's just it's just the way it is. It's just how that kind of margin of error, based on the fact that even though we surveyed 1,000 people, we could still be off as anywhere from 3% above or below uh, here. Okay, so that's kind of how the idea works with margin of error. Uh, so let's consider a second example. Let's consider a second example here. This one here was a survey from quite a while back, um, where they were ranking, they surveyed 850 people. This was probably 850 Republicans, and they were asking who would they want for president. And in this particular survey, uh, Trump got 50%, and the next closest person to him was DeSantis, who got 15%. So once again, we want to compute the margin of error and basically see uh, where could Trump's range be of support in this particular survey, which is a pretty old survey because if you've been following anything with politics, DeSantis isn't even running anymore. So this is a pretty old survey. It's actually from back in October uh, that I found this one. But same idea here. We compute margin of error by just taking 1 divided by the square root of the number surveyed, and we just compute that on a calculator. 1 divided by square root of 850. We get 0.0343 if we round off. 0.0343, so that would be 3.43%. And then we just take our Trump value, subtract it off, 50 minus that. That would be the lower level from this survey of 46.57%. And then we take and add that on, 3.43. So in this particular survey, we can say that we're pretty confident that somewhere between 46.5 and 53.5% in this survey or the people that this survey represents, supported Trump. Okay. So that's what we call, again, margin of error. Now, there's one other thing I would like you to take a look at. Um, this is something you can do on your own. If you go into our course, uh, underneath Gradebook is a link called Course Links. And the very first link up there says Deceptive Statistics Examples. So please take a look at that. Read through that, as it will show you some various examples that have uh, historically been done where they've just done a really bad job with choices that kind of make the results stand out kind of as bad examples of statistics, bad choices, either intentionally or unintentionally, that kind of deceive people. Because you're going to run into a couple of examples in this homework on deceptive statistics. Okay, so please check that out. Again, that link is underneath the gradebook. Course links, deceptive statistics. Please read through that website. If you are interested, there is a second link you can check out for more information. But I just want you to look over the ones in the first one there. Okay, deceptive statistics. So please check that out. So that brings us to the end of this chapter. So uh, So I'm going to put up another video right after this where I'm going to give a brief overview of your test. So I'll catch you in that one in just a moment.